Good evening, everyone, and welcome to day 2 of our session, that is data analysis with R. So a recap of what we treated yesterday. So yesterday we talked about data analysis and also data analysis using R. We gave an introduction on R. I can also customize your R and R Studio, the differences between R and R Studio. We also talked about variables, what are variables, and how you can store values into variables. We also talked about comments. So these are what we treated in yesterday's class. So we're going to be continuing today, and we'll be talking about arithmetic and logical operations in R. So we're going to be talking about the operations which one can do, which are the arithmetic and logical operations. So we have various operations which can do with values of variables in R. So if, for example, now you can see now currently I have a list of operators in R. So you can see the first is addition. So let's say, for example, I have a variable x. So I'm going to be calling x is going to be 5. I also have a variable 7. So I've already given y as I've stored y, the variable y, I've stored it with the value of 7. So I can now use the addition operator, which is going to be x plus y. You can see I'm going to be having 12. So I also have the subtraction operator. I can say x minus y. So you can see we're having minus 2. So the subtraction operator, and we also have the multiplication operator, that which is x asterisk y, and you can see we're having 35. We also have division operator. You can say x divided by y. You can see we're having a decimal digit. We also have the exponential operator. So this is raised to the power. So if we want to say 2 raised to the power of 4, we're going to write it as this. We use the exponential symbol. 2 raised to the power of 4, and we see we have 16. We can just say x raised to the power of y. You can see we have 78,125. So we have integer division. So what integer division actually does is that it divides a number by a number without what giving the remainder. It only gives what the number goes into. So let's say, for example, now we know that 2 can go into 8 4 times. So, but what if 2 go into 9? So normally, if I say 9 divided by 2, I'm going to be having 4.5. But we're not interested in the remainder. So this is where we now use the integer division. I can now say 9, and I now use this sign, the percent sign, then slash, then also percent sign, divided by what? 2. So I can just give a space here to make it easy to understand. So you can see now here I'm going to be having 4. So I'm not going to be having the remainder, unlike this particular regular division which I did in this place. So when you use the integer division, you're going to be surrounding the slash sign with percentage. So this is going to divide a number by a number, giving only the number of times that particular number goes into it. So 2 can go into 9 4 times, remaining only 1. So we're not interested in the remainder, we're going to be having 4. The same thing also, I can say 13. If I say 13 divided by 2, I'm going to be having 6.5. But if I'm going to be using the integer division sign, it's going to be 13. So welcome everyone. Welcome, Mr. Oladimeji and Mr. Higgats.
Thank you very much. I totally forgot. I'm so sorry.
No problem. So maybe I'll just give you a short summary of what I've already been doing. So I'm just talking about operators now. So the operators you can use and which you can use to perform operations in between variables and also between values. So you can see now the first operator here is the addition sign, which you see I just did now. You can see it's x plus y. And also we have the subtraction symbol, we have the multiplication, we have the division, and also have the exponential. So the exponential is just the raise to the power symbol. So the raise to the power symbol is you are going to see it on your numeric keypad. Then we now have what we call integer division. So you want to divide a number by a number, and you are only interested in the number of times that particular number goes into it. So for example, you want to divide 30 by 2. So when you say 13 divided by 2, you are going to be expecting a decimal number. So 13 divided by 2 now will be expecting a decimal number. But we only want what the number of times 2 goes into 13. We are not interested in the remainder. So this is why I'm now going to be using the integer division. So the integer division surrounds the slash symbol with the percent symbol. So now 13 integer divided by 2, you can see we are going to be having 6. The same thing also if I say 13 integer divided by 3, you can see we are going to be having 4. But if I use the regular division symbol, you can see I'm having what 4.333. So this symbol only gives you what the number of times that number goes into the number you want to divide. Why you also have remainder division. So this is like the opposite of integer division. So in remainder division, now you're interested in the remainder. So if I say 9 remainder divided by, or you can just modulo division. We also call it the modulo division. So if I say 9 modulo divided by 2, we're going to be having 1, which is actually the remainder. So you can see it. So what if I now say is 2 modulo divided by 4? You can see we're having what? 2, because 4 cannot go into 2. So we're going to be left with what? 2. So the integer division gives you the number of times that a particular number goes into a bigger number, while the remainder division gives you the remainder if you divide that number by another number. So this is just the difference between these particular 2 types of division. You can see both of them have the percentage sign in common. So in the remainder division, we have 2%, while in the integer division, we have a slash symbol surrounded by percent. So these are the arithmetic operators which we have in R. So you can see an example of a complex arithmetic operation. So it also applies the principle of board mass. So anything that's in the bracket is going to be taken care of now. So you can see currently now we have variables A, which is equal to 8. We also have variables B is equal to 9. And we have variable Z, which is A plus B. You can see it. And then we also have Y, which is equal to X and is equal to what? Z. So yeah, what we did now is that we assign the value of Z. You can see the value of Z now, which we have here. So let me call Z. So Z is 17. So I assign the value of Z to X. And X will now also assign the value of X, which is 17, also what to Y. Then we now want to find a variable called U. So U is going to be A plus B in brackets. Then Y divided by X also in brackets. Then it's now going to be multiplying these particular 2 values here. Also add it with Z raised to the power of 5 minus 10,000. They will now have the value of U. So if you want to run multiple cells, multiple lines of codes together, you just highlight it. So when you highlight it, Control Enter, it's going to run everything for you. So in this particular chunk, it is going to run all this particular line of code for me. And you see, I'm only having 2 values here because what? You can see I called the value of U in this place. So I call the value of U. So U is, okay, I think also that of B. Okay, yeah, this is, let me remove this. Okay, so when we run the whole of this line of code now, we only have the value of U because it is only the variable U I called. So assuming I've already called that of A and B, I'm also going to be having their values. So we also have other operators too, which you can use. We have comparison operators. So comparison operators allows you to be able to make comparison between variables or between values. So now the first comparison operator we have is equality. So this is very important to take note. There's a difference between equality and also assignments. So assignments can be this: X is equals to 5. You can see this is assignment where you now get a new variable called X. But equality is when you want to check if 2 numbers are equal to each other. So if you want to check if 5 is equals to 6, you can see now this is what's called the equality operator. You are checking if 5 is what equals to 6. You cannot say 5 is equals to 6. You're going to get an error. You can see it. You're going to be having an error because you cannot assign a numeric value. Just like I said, inside variable naming, you cannot have a variable that is just a numeric, either starting with a numeric character or is just only a numeric character. So this is why you see we are going to return an error. So you want to check whether 2 values or 2 values are equal to each other. Like now we have X and Y stored already. If you check here. So if you check here, you can see X and Y. By the way, if you want to clean all these variables you have, you just click on this particular cleaner. You can see it clear objects from the workspace. When you click on it, you see everything is going to be cleared. So if I'm to now call X now, you can see that what object X is not found. So which means I've already cleared all the variables you have in your work, in your environment or in your workspace. You have cleared all those particular values. So you need to store them again for you to be able to use it. So now, if I want to say X now is equals to, I have a variable now called X is equals to 5. And I have Y is equals to 67. Now, if I want to check whether X and Y equals to each other, I'll now use the equality operator. X is what equals to X is equals to Y. So you can see it is what returning false one. So we call this a Boolean value. So Boolean value are just 2, either true or false. That's why we call it a Boolean value. When we say something is a Boolean value, you either have what a true or a false. So in most cases, true represents 1, while false represents 0. So now we just check if S is what equals to Y using what the equality operator. Then we also have other operators like the not equals to now. So the not equals to is like the opposite of the equals to. So X not equals to Y. So you can see we're having what's true. So which means that what? Because X is truly what not equals to Y. So this is just the two Boolean values you have. So we call this comparison operators. And when you use comparison operators, you're expecting either of two values, either true or false. You cannot have any other value except this particular values. Either it is true or it is what? False. So now we also have the greater than sign, greater than symbol. You want to check if a particular value is greater than another value. So like our X now, we want to check if it is greater than Y, which is what? False, because our X is 5 and our Y is 7. We also have the less than symbol. X is less than Y, which is true. And we have the less than or equals to. So let's say now we have false 5. And we say less than or equals to what? 5. But this statement is actually going to turn true because 5 is actually not less than 5, but it is what equals to 5. So since it is equals to 5, the statement is going to return what? True. So which means at least one of these particular conditions must be satisfied. And it is also possible that what? 5 can, it's also possible that 5 can actually be less than a number. Let's say 5 is less than 3. So less than or equals to what? 3. So in this situation now, 5 is less than, 5 is not less than 3. Or okay, let me put it as 7. 5 is less than 7 now in this situation, but it's not what equals to 7. But it has already satisfied one condition, then it is going to what? We are going to be getting true. But if I now say 5 is less than or equals to 3, so we can say that 5 is not less than 3 and it's also not equals to 3. So we're going to be having false. So this is how the comparison operators actually work. They also have the greater than or equals to also, which you can also use to check if a particular variable or value is greater than or equals to another value. Then we now have what's called the logical operators. So logical operators are actually what? There are 3. We have and, we have or, and we have not. So in other programming language, you can just write it like this, not, or they just write it like this, what in as and. But in R, you use the ampersand symbol for and. So you want to check whether, let's say for example now, we have let's say 2 is less than 3. Then we now have and let's say 4 is equals to 4. Okay, 4 is equals to 7. And we now run enter. So we have false. So one thing you should note with the and is that the and, if at least one of these particular statements you can see is false, then what your resulting output is going to be what? False. So if at least one of these statements is what? False, you can see that 2 is less than 3, but 4 is what? Not equals to 7. So what? We are going to be what? Having what? False. So this is the AND logical operator. So the for AND logical operator, for an AND statement to return a true, all the statements have to be true. So for us to be able to get true, we need to what? Say 4 is now what? Equals to 4. They are not going to be having what? True. But if we now say 2 is what? Greater than 3, you see, you are going to be having what? False. So when you have false, false, and false and false, you are going to be having what? False. When you have true and false, you are still going to be having false. When you also have false and true, you are going to be having false. But if you have true and true, you will be having what's true. So it's only in one situation where all the what conditions are met. That's when you are going to be what? Having true. So and this and what? This. So, but what of the or? The or logical operator is actually like an opposite of the and. So the or operator only returns false when all the what conditions are what's false. So now if I'm having what? 2 less than 3, and I'll say or. So the or, you actually use the pipe operator. So this is, you're going to see this above your enter key on your keyboard. Then what? 4 is equals to 4. So you can see that 2 is less than 3, or 4 is equals to 7 or 8. Let me do it like this. So you can see that 2 is actually less than 3, which is what? This statement is actually true. You will now see or 4 is what? Equals to it. So 4 is what's actually not equals to it. So if I were to actually have used the AND operator, we're going to be having a false. But because this is the or, when I run it, we're going to be having what's true. So for your or statement to return a false, both what conditions have to be false. So that means when you have a true and a true, if you have a true and a true, then you are going to be having a true or a true. You are going to be having a true. If you have a true or a false, you are going to be having a true. a false or a true, you're going to be having a true. Then if false and a false or a false, you're going to be having a false. So that's only when you have a what's false, when you use the or. So the importance of this particular logical operator and comparative operators is when you're analyzing data and you want to be filtering data. The situation where, let's say, for example, you're analyzing sales of a particular items. You now have to find out items that are below the mean prices or average prices. Okay, sorry everyone for the interruption. Are we still there? Hello?
Yes, we are here. And our second instructor, welcome.
Okay, sorry for the instructor. So allow me to introduce my colleague, that's Ms. Faida Bukola Bello, and also Ms. Belikisu. Thank you for joining us. Okay, so I was actually at the logical operator. So I've already explained the AND, which is the ampersand symbol, and the OR, which is the pipe symbol. And the next one is going to be the NOT. So the NOT is just like a complement. So when a statement is true, the NOT the result makes it to false. So now we are having a 2 is less than, which is actually true. So which is actually true. But when we use the NOT symbol now, this statement now becomes what? False. So it's it gives us the complement of this particular Boolean value. So this is just the logical operators and, or, and, not. Then we also have the comparison operators, which you can see them, they are 6. So next, we're now going to be talking about data types. So what are the major data types we have in R? So data types, is important to know your data type so that you'll be able to know how you can handle a particular variable, because most of the things you store in a variable can come in different data type formats. And some of the most common one we've already used we have already used a text, or we can say a string data type. We have also used a numeric data type. So the first data type now I'm going to be talking about is a numeric data type. So a numeric data type are usually numbers. So, and they have usually numbers that are having decimal points. So for example, now we have a digit, let's say A is equals to 4.5. So you can see it now. When we call it A, you can see that this is number with a decimal point. So these are numbers that are on a continuous scale. So any number that is having a decimal point and is also measured on a continuous scale, we call it a numeric data type. They also have an integer data type. So these are numbers that are not, this is like on a counting scale. So they don't have decimal points. So for you to store an integer data type, you are going to adding an L at the end. So when you say C is equal to 3L, that is going to detect it as an integer data type. So you can see the values are already created. Now you can see our integer here, which we created, which was C. I can see our numeric, which is we created here, which was A. That is 4.5. So what if I now want to store a particular variable now D? I now say D is equal to what? 45.3, and now put L at the end, and I run this. I'm going to be having an error because this particular L is meant for integer data type. And this cannot be an integer when it's actually carrying a decimal point. So 45.3L is going to be returning an error instead of it creating a variable as an integer. So we also have character data type. So these are values or in text format. So values in text format are usually enclosed in quotes. So if you want to store a value in text, I already explained this in yesterday's class. I'm not just going to be saying, for example, now you have name, now say John. So this is going to actually return an error for you because it's going to be looking for a variable name called John. So you need to enclose this particular name. You need to enclose it in quotation mark. And when you now use the script editor self, you are going to be having it in syntax highlighting. So when you see a text covered in green, it means it is a text value which is going to be assigned to a variable. Like now here we have name is equal to Joy. We also have sex is equal to me. By the time we now run this now, we're going to be having character variables created. So this is where I now say that this particular variable is a character data type. They also have the logical, which I just explained now. That is true or false. It's just two values. Either it is true or it is false. So a logical value or a Boolean value usually fall between just these two values. Either it is true or it is false. So now you can also use the class function now. So the class function allows you to be able to check for the class of a particular data type. So now let's check for the class of these variables I've already created now. I can check for the class of A. You can see that A returns numeric. So you can see because it's having a decimal point. So what if we check for the class of C? So you can see C returns an integer. You can see 3L. And if we also check for the class of D, you can see D also returns numeric because it's having a decimal point. We also check for the class of name, which is actually a class of name. You can see that class of name is a character. So we either characters or string or text. So you can see that is a character. And so check for the class of sex also. So you can see it's also a character. So this is the function we use to check for the type of data type of a particular variable. And also one more thing, if you see a function if you come across a function which you don't know about, you can use the question mark symbol before that particular function to get help on that particular function. So you're going to see the help pane is going to be opened for you. So here now you can now see details of this particular function. And most of the time at the extreme end, you see examples related to that particular function. And also if we use the question mark also on the print function, which we used here in yesterday's class to get the value of a variable, you can also see, we call this a documentation of this particular function. So the documentation usually contains definition of the function and also how the function works, and also examples which shows you how you can use that particular function. Because we're going to be treating a lot of functions, so very important to really check the documentation of a function so you can see how you can use this particular function and also interact with this particular function. And also when you are typing a function on your script editor now, let's say I'm typing C. Now let me just type pre-R. So most of the times you are going to be seeing so you are going to be seeing options related to this. We just call this like an IntelliSense. That's to just show you other functions that are sharing this particular beginning. So let's say, for example, functions are starting with PRIN. I'm going to be seeing functions that are starting with this particular phrase so that you can be able to view which particular function do you want to use. So if it is print, you can see we have various type of print function. I also have the pure print itself. I think, where is it? Okay, yeah, this is it. So this is the regular print which I'll be using. I also have other functions. So when you're typing a function and you don't remember this particular function you want to use, you can see the options there. I can also choose from it. And you want to know more about this particular function, you just check for the documentation of that function. So this is for the class function, which allows you to check for the data type of a particular variable. So we now have what we call data structures. So data structures are usually used in storing more than one particular value. So the most basic data structure, which we treated yesterday, was a vector, where you want to store multiple values into a single variables. But when you store those particular where we use the combine function. So just a recap, let's say we have a variable called t. Then I now use the combine function to now store 2, 3, 4. So you can see it. So the question I would have expected people to ask yesterday was that what if I'm to use t and now say c, and I'll say 2, then okay, let me just do this as boy, and 3 and 4. So what am I going to be expecting now in this place? So now I'm having various data types. I'm storing various data types now into a single variable now. So when I run this now, what should I be expecting? I will not expect an error. So that's what we call cohesion. So when you have a combination of a character data type and also a numeric data type, so R is going to convert those particular numeric data type into characters. So you can see now this numeric, these data types now that we're using, these number data types that we're having now, 3 and 4, they're having quotation marks. So which means that these numbers cannot be used for calculation. So they are no more integer, they are no more numeric, they are characters. So you cannot use these particular numbers for calculations. So this is one of the reasons why we have data structures in R. The situation might arise Yeah, sorry everyone. So where was I before I got disconnected? Hello.
Yes, you just mentioned that there will be coercion when a
Oh,
vector is storing more than one data type.
okay.
The preference is character, so it converts all of those to character.
Okay, I think this aspect, right? This side. Mhm. Okay, so what I was just trying to say is that when with the first data structure we have is actually the vectors. So, but one lapse with the vector is that the vector actually stores data that actually stores values of the same data types. So if you're having numeric, you're going to be having numeric all true. And if you're having character, you're going to be having character all true. If you're having Boolean, you're going to be having Boolean all true. So for example, now if I'm having like let's say I'm having R, and let's say C true, and then as have false. So and I have one particular number here. So let's say I have 4. So what will happen now when I run this? So you can see now it has already converted what all of them towards characters. So because you cannot convert this particular 4 to a Boolean value, and let's say this particular false now cannot be converted also to numeric. So already have what all of them as represented as character. Though I actually study true as character. So let me just say R is C, true, and false. Then we have 4. So when I call R now, okay. So now the numeric value of true is 1, and the numeric value of false is 0. So you can see now because we're already giving a Boolean value to get us a numeric value. So the Boolean values are now going to be converted to numeric values. So you can see we're now having what 1, 0, and 4. So in this situation now, they are not actually Boolean value, they are string value because of these quotation marks. So this is what differentiates this particular true here with this particular true here. So because it is surrounded by quotation mark, it makes it a string. So because these two are both characters, then this particular 4 is now going to be coerced to become a character. And also because this particular value here, 4 is a numeric, so it is going to convert this Boolean value true and false to numeric. That is why we're having what 1, 0, and 4. So because of this now, we now have what we call a list. So unlike the character, unlike the vector, the list allows you to store values of different data types. So you can now see, for example, this is a variable now, colors. So we have various colors which I've already stored in this particular variable. So all through here now we're having what characters. And so we have blue, we have green, yellow, black, and white. So all of these are characters. And also when you look at this, also all of these are vector of numeric values. You can see it's prime numbers. So you can see we have vector of numeric values, also have vector of logical values. So in a vector, you are going to be having the same data types all through. So you can also check for the length of a vector. So if you have a vector now, like now, this is a vector that was created now. We have 3 names here. We have John, we have Joy, we have John, we have Jamal. So now this variable names now was created with 3 names. So you can check for the length of this particular variable now using the length function. So this is another function that allows you to check the length of a vector. So now when I run names, and I also run length of names, you can see I'm going to be having 3, which is the length of my variable. If I'm also to add another value here, let's say I'm going to be calling this, I'm just going to Jacob, I'm going to call this Mary. So when I run this now and I run for the length names, you can see I'm going to be having what 5. I can also check for the documentation of this particular function. So you can see I'm going to be having a description of it. So length of an object, so it's what allows you to get or set the length of a vector. So this is an example of how the documentation works. And below also I'll be seeing an example of where it was actually applied to get the length of a particular vector. So not only vector, you can also apply it to get the length of other data structures which you are going to be coming across in R. And also you can sort a vector with the sort function. So we also have a function called sort. So you can see now we have a variable of numbers, but these numbers you can see that actually was scattered. So when I run this particular variable numbers and I run the sort function on the numbers, so you can see now these numbers have been sorted in ascending order from 0 to the highest number, which is 14. So this is what the sort function allows us to be able to do. So it allows you to be able to sort a group of numbers. So what if I now have, can I apply it now on a character? So let's try that. So let's say, for example, now I have a variable x, y. I can just call this, let's say this is going to be apple, and this is going to be, let's say, zebra. This is going to be fish. Something like this. So let's apply sort now on y, and let's see what do we have. So you can see it now, it is in alphabetic order from A, that's then to F, then to Z. So you can see that it has already sorted what this particular vector in alphabetic order. So this is what the sort does for you. To help you sort a particular variable for you, or let's say a particular vector for you. So if you have a vector of numbers and which are scattered, you sort it in what it's going to sort that particular number for you. So now when you now check for the sort documentation now, so you can see now we have what we call argument, so which allows you to what, because if you check it now, this sorts now by default now it sorts your number now in what, ascending order. So what if now to sort it in what, descending order? So I'm now going to what, we call this argument, so that allow you to be able to what, tune your function to do what you want it to do. So by default, that's what the function is going to do for you. But by using the argument, you are allowed to also do what, something more advanced than what is actually designed for. So if you want to sort these particular numbers now in a descending order now, you can just give decreasing now, decreasing. You can see decreasing is equal to true. And I run this. So you can see now these particular numbers are going to be in decreasing order. So that's from the highest to the lowest, which is what, 0. And also apply that to also on our y variable, which is containing an sort y. I can now see decreasing is equals to true. So you can now see it is starting from the last letter, which is Z, up to the first letter, which is E. So this is how you can also set the, this is how you can use functions. I also use what, arguments inside what, functions. So a lot of the times I'm going to be making use of this particular argument so that you can be able to what, tune the function to do what you want to do for you. So how do you now access the item in a vector? So now you have a vector now of items. Let's say now you have a vector of fruits. So here we're having banana. So we're having banana in this place. And we're having orange, watermelon, and purple. So we're having, you can see we're having 5 fruits inside this particular vector now. So now if I want to now access the elements of this particular variable called fruits, now how do I do that? So first of all, let me run this variable fruits. Now, if I want to access the elements inside this particular vector, I use what we know as called square brackets. So you can see this particular square brackets now. So any number that's going to be here is going to be the index number of a particular value in this particular vector. So we have banana now, which is carrying index number of 1. We have orange, which is carrying index number of 2. We have water, which is carrying index watermelon, which is actually 3. Yeah, 3. Then we have purple, which is 4. So now if I'm to say fruits in square brackets of 3, so the value I'm going to be having is going to be watermelon, because watermelon is carrying the value of the index value of 3 in this place. So any value or any digit that goes into your square bracket is the index number of that particular element you want to retrieve. And what if I now use a negative indexing now? So when I use what, fruits minus 1, it allows you to access all the items except what, the one specified. So now it excludes what, the first one. So all my items is going to come out. I'm going to retrieve all the items in this particular vector, except the one I want to specify. That's using this particular negative sign. What if I now say negative of 4? So when I say negative of 4, you can see we're having banana, we're having orange, and we're having watermelon, but we're not having what's purple. So the same thing also applies if I say negative of 3. I'm going to be having all the elements except what's the third element, which is what, watermelon. So in R, unlike other programming languages, indexing usually starts from 1. But majority of programming language, you see that indexing will be starting from 0. But in R, the indexing starts from 1. So your counting is going to be starting from 1, 2, then 3, then 4. And also you're going to be using the square brackets to be able to access all the elements inside the particular vector. So what if you now want to access multiple elements, you also use the combine function too also in this place. So you want to access fruit 2 and you also want to access fruit 3. You use the combine function. So this combine function is going to be taking this particular index numbers you want to use. You can't use fruits and now say you want to just give 2, 3. So this is not going to work. So you need to use the combine function. So when you are typing fruits, then you use the combine function because you want to in this situation now you are combining two. You should remember that you're combining two data to the 2 values together. And when you're combining 2 values together, you always use the combine function. But when you are assigning just a single value, you can just give the single value. But when we're having 2 values, use the combine functions. I'm going to be now using 2, 3. So you can see I'm now having the element orange. I'm also going to be having the element watermelon. So we now have lists. So list is what you now use when you're having various values.
My hand is up.
Okay.
So what if you want to access the last element? Like you don't know how many elements you have in a vector, but you want to access the last element.
Okay. I want to access the last element in a vector.
Like in other programming languages, now when you say index of -1, it gives you the last element. But here it's removing that number. So I'm just wondering.
Okay. So first of all, I think the best thing we will do is to get the length of that particular vector. So for example, now if you have a vector of elements 100, you just use the length function to get the vector. Okay, let's say for example now, let's just take this. Let's create this particular vector now, 2, 3, 4, 5, 6. So let's just assume this is a very long vector, which we don't know the number of elements inside it. So I can just say length of x, and I have 5. So I can now say x, that's going to be length x5. So x5 is going to give me 6. So instead of now using just typing this length of x, I can now say x, then I can now, inside the square bracket, I'll now say length of x. Okay, sorry. Length of x. So you can see I'm going to be having 6. So if I want to access the second to the last element, so that's going to be length -1, which is 5. So I don't know if you're getting me, Mr. Language. So this is the function I'm going to be using. You're going to be using the length function. So the length function, no matter how long your vector is going to give you the number of items in that particular vector. So if it is that particular last element you're interested in, you just use only the length of that particular vector inside the square bracket. Or if it is second to the last, you use length of x -2. If it is the third to the last, you use length of x -3, and so on and so forth. So that's what we go. Second to the last, use length of x -1. Then third to the last, use length of x -2. So you go on like that. So you're going to be using the length function. You want to access the last element in the particular vector. So I don't know if that's clear.
Yeah, it's clear. Thank you so much.
Yeah, okay. So we now have a list. So situation where you now have various values, various values with different data types. You now use the lists data structure. So you have various values and they are carrying different data types. You have numeric, you have character, you have Boolean. So this is where the list is now going to come in. So the list is going to contain different, it's not going to coerce any of this particular data type into another data type. It's just going to keep it the way you give in the value. So example of a list now, you can see here now in this variable, my list, I'm having Kano, Gombe, and Bauchi. So these are character data types. Then I'm also having one particular Boolean value here, which is true. And also have numeric 8 and 20. So when I now run this now, I can see I run my list. Then I'm to call this particular variable my list. So I'm going to be having a list. So what this actually means is that, so you are going to see that the output is different from what you get from a vector. So this particular number you see here is the list number. So you can see this is list number 1. So that's element number 1. The elements number, we have elements number 2, 3, 4, 5, and 6, and so forth. So one thing with lists is that you can actually have a list inside a list or a vector inside a list. So for example, now in this my list now, I can just use comma, then say C2, 3, 4, enter. So when I call my list now, so you're going to be seeing what this new element I added now, you can see what it lists 2, 3, and 4. You can see that I'm having what 2, 3, and 4. I can also have a list also inside a list. I can actually say lists of 2, 3, 4. And when I call my lists, I'm going to be having what? Here is it. So you can see this list I just added now. This last element I added now. 2, 3, and 4. Okay, this is the vector I added now. So this is the new list I added now. You can see it here now. 2, 3, and 4. So what this square bracket actually means is just the positioning of the list. So let me explain it now. So you can see this is element 7 and this is element 8. So you can see element 8 now is a list. So under element 8 now, we have what 2, 3, and 4. So you can see it now here. So if you want to access the element of a list now, we are going to be using the square bracket. So we will use my list square bracket of 1. I have what scan. So what if that particular element now is a list? They are now going to add another square bracket. So I'm going to use my list. So like that of this particular list now, which is element 8. So this is 8. Now I'm going to use my list. This is 8. So you see I have this. I now have what all these lists I have. Then if I want to access this element inside this particular list, I'm now going to use my lists. Our index is by 8. They are now indexed by what 2. Okay, so let me use square brackets, double square brackets. 8. Okay. So now we're going to be using a double square bracket. So the double square bracket is going to get the value of that particular index number which you are interested in, which you can see is this particular list. And also under this particular list, we see we're having what 3 elements. So when you add also another index into, which is currently now I'm adding 1, you're going to be having what your first element. So if I change it to 2 now, you can see that I'm going to be having what the second element. So the list can contain various data types and can also contain what a list inside a list. So when you use your square brackets, either you use a single square bracket or use a double square bracket, you're still going to be getting the same result. So what if you now want to change the value of an item inside a list now? So inside our list that we just created now, we want to change the value of the elements. That's element with index number 4. So I'm just going to assign. First of all, you index it. So let's say, for example, now this is my list of 4, which is true. So I'm now going to assign this particular position now. I'm going to be assigning it to a value now. I can just call this a boy. And when I now call my list, you can see that it has what changed it to what from true. It has already changed it to boy. So you just use your square brackets to assign a new value to that particular position, and it's going to change it for you inside your list. I can also remove items by using the negative indexing in a list. So let's say I run my lists. So let me just create a simple list now, just for example purpose, and say list 2, 3, 4. So now this is my list now containing 3 elements. So if I'm to now call my list using a negative indexing, so let's say I say negative of 2. So you can see now currently now just like the vector that I explained earlier on now, you can see that the second element has already been removed. So you can see the second element has been removed. If I also say my lists and I said -1, you can see that the first element has also been removed. So when you apply a negative indexing inside the square bracket, it removes the position, it removes that particular value inside that particular list, just like it removes a value inside a vector when you use the negative indexing. I can also add an item to the end of a list with the append function. So the append is also another function that allows you to add items to the end of a list. So now if I'm to call the append function now and I give in my list first, after giving my list, I now give the value that I want to append. So let's say I want to append us now to this particular list, my list. So you can see now us has already been added to this list. When you check your environment now, you're going to be seeing the details of all the values we have been creating. And you're also going to be seeing their data types. You can see the variables we created earlier on, like that of T, which is a vector. So you're going to be seeing what the data type, which is character, and you also see the range of the indexing. So you can see from what 1 to 3. So even if you're having 100 values, you're going to be seeing from 1 to 100, and you also see a list of the elements inside this particular data type. If the variable doesn't have much elements, it's possible for you to see all the elements inside that particular vector, or maybe if it's a list. Or if it is much, then you're going to be seeing these 3 dots, which means there are other elements also after that particular element that's already shown for you. Like this particular variable now, names. You can see we have Joy, John, Jamal, and Jacob. We also have other elements there. So now we also have another data structure now called matrices. So matrices are actually two-dimensional data made up of columns and rows. And for you to create a matrix, you need to use the matrix function. So now if you want to create a matrix now, let's say you want to create a matrix of 2 rows and 2 columns. So that is a 2 by 2 matrix. You're going to be using the matrix function. So first of all, you type in the matrix function. So the matrix function takes the vector that you want to give in. So that vector is going to be containing the elements you want to be stored in that particular matrix. So let's say inside the 2 by 2 matrix now, you want to have 1, 2, 3, and 4. So we're going to be giving your vector of 1, 2, 3, then 4. Then you now give your number of rows, which is the n row argument. So the n rows determines what your number of rows, which in this situation is 2. Then also have the n column, which is also what 2. So when you now run this, I see you're going to be having a 2 by 2 matrix. So we have what 1, you can see we have 2, then we have 3, then we have what 4. So we also have an argument called by row. So you can see now in this place now, let's check now the matrix function. The documentation for the matrix function. So when you check the documentation for the matrix function, you can see by default, the by row is equal to what false. So that means how is the matrix function going to be assigning the values? Is it by rows or by columns? So you can see now currently the matrix function is assigning it by column. So you can see inside the first column, we're going to be having 1. Then in that particular column, we're going to be having 2. So what if I now set it's what by row is equal to what true? So I say by row is going to be equal to true. So you can see now it has already changed. So it is assigning the values by row. So 1, 2, 3, and 4. So to explain it better, let's also create a 3 by 3 matrix. So a 3 by 3 matrix is going to be containing 9 values. So I'm going to give in my matrix function, then which means since I'm going to be having 9 values, I will be creating a vector of 9 elements. So I'm going to be using the combine function of 1, 2, and the element I'll be storing is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 elements, and the number of rows I'll be having is going to be equal to 3. Since we are talking about a 3 by 3 matrix, and the number of columns is going to be equals to 3 also. So for now, let's just leave the by row is equal to false, which is what is the default. So you can see now we have a 3 by 3 matrix. So since by row is equal to false, it means what? The values are being assigned in the matrix by column. So you can see we're having 1, 2, 3, then the next column 4, 5, 6, then the next column 7, 8, 9. But now if we are to set it now to by row is equals to let's say true. So you can now see now it's going to be assigned row wise. So 1, 2, 3, 4, 5, 6, then 7, 8, 9. So this is how we can create a matrix in R, and the matrix is also a data structure which you are likely to be coming across in R. So it's not necessary also that your matrix is numeric. You can also have a matrix of string or characters. So you can see now for this particular matrix now, we have blue, white, red, and green. So this is a 2 by 2 matrix. So now I'm going to call this particular string matrix now. So you can see we're having what's blue, red, also white, and also have green. So now how do you now access the elements of a matrix? So let's say I've already created a matrix now. So this is a matrix of prime numbers now. You can see we have a number of columns because of 3. So now what we just did here now is that we just gave only the number of columns to be equals to 3. So by default now, that means it's going to what now. So from the vectors we already gave, it will now decide the number of rows. So we only gave the number of columns to be equals to 3. So now let's now view this particular matrix and see that since number of columns is equals to 3, it will now use the number of elements we have to now decide how many rows we are now going to be having. So you can see that since we're having 9 elements, and we also have 9 columns, it means the number of rows is now going to be what? Its number of rows is going to be 3. So if we now want to access the elements inside a matrix, first of all, in your square bracket, you are going to be giving your row number, then you now give your column number. So now you want to access row 2, column 1. So you can see row 2, column 1, your square bracket. First of all, you give your row number, then you give your column number. So when you access row 2, column 1 is now going to be 3. So you can see this is row 2, and this is what's column. You can see this is column 1. This is column 1 that we're having here, which is now 3. And also, what if we want to access only the elements in column 3? So you just give, you're not going to give any value, but you give a comma, then that particular, then the number of that particular column which you are interested in. So which is 17, 9, and 23. So you can see all the elements we have in column 3. You can also say prime. You can also say prime, comma 2. So 7, 11, and 13. So what I can also exchange it and say I'm only interested in a particular row and not in a particular column. So if I'm only interested in row 2, you can see if I'm only interested in only row 2, you can see I have all the elements in row 2, which is 3, 11, and 19. So this is how you can access the elements inside a particular, inside a matrix variable. And also this line of code here allows you to be able to access more than one row. You can see here we're having row 2, we're also having row 3. So this one is excluding row 1. So here now we are excluded row 1. So if you check our row 1 here, we can see which is 2, 7, and 17. So row 1 has already been excluded, but we've already included row 2 and 3, and also because we did not give any value for our columns, all the columns have already been included. So we also have the add bind and the C bind function allows you to add rows and columns to a matrix. So now if I want to now add another additional row to my matrix, I'm going to be using the add bind. So the add bind means row bind. So that is, I'm going to be giving a vector of the number of the same length as the number of rows I have in my matrix. So that vector is now going to be added to that particular matrix, and we have a new dimension. So now if you check my prime matrix now, you can see it is 3 by 3. So when I now use the add bind on the prime matrix, add bind, so it's going to be taking your matrix first, then which vector are you adding to it? So currently I can say I'm just adding vector 1, 2, and 3. So you can see now it has already added this new vector I gave by the row. So the column, but it has to be the same number of elements as the one that you're also having in the matrix. So if I use C bind now, I give my matrix, and after giving my matrix, I'm going to be using C1, 2, 3. So you can see I've already added it. I've already added a new column to my matrix. So you can even create a new matrix also using this add bind and C bind. So you just assign it to a new variable and you create a new matrix with it. So just like it was done in this place now, you can see now add bind, we're adding we're adding a row 29, 31, and 37 to a variable called new matrix. And when you run new matrix, you can see the value we have in new matrix. And also we have C bind. So let me just change this to a new matrix. New matrix. And since our matrix now is having 4, so new matrix, we're having columns, I'll just put this as 41. So we're calling new matrix now. So you can see now I've already added another extra column to this particular matrices. So this is how you can add new rows and can also add new columns to your matrices. And the dimension function allows you to check the dimension of your matrix. So if you have a very big matrix, you want to know how many rows or how many columns you are dealing with, you just use dimension, and what is going to be taken in is going to be the name of your matrix. So just like prime now, you can see the dimension is 3 rows, 3 columns. And that of our new matrix is what 4 rows and 4 columns. So the dimension function allows you to check for the dimension of a particular metric. So how many rows a metric have and how many columns a metric have. So we're going to be stopping here today, and tomorrow we're going to be looking at other data structure, which are arrays, and also we're going to be looking at data frames. So tomorrow we're going to be looking at arrays, we'll also look at data frames, and also do a case study. So we're going to be doing a case study on a data set. We're going to be analyzing a data set, and also we're going to be talking about packages, how you can load packages into R. How you can also install external packages, because not all functions are available in R by default. So you need to be able to install external packages for you to be able to use some functions that you can now use in performing your data analysis. So I don't know, is there any questions?
I don't have any question.
Okay.
You have done a good job. Thank you so much.
Okay. Mr. Fikat?
No question from my end, so thank you.
Okay, you're welcome. So tomorrow we'll talk about the arrays and the data frames, data structures in R, and also we conduct a case study in R so that you can see how the data analysis workflow in R looks like.
Thank you.
You're welcome. I think that's it for today. Okay, so I don't know if my colleagues have anything to say. Okay. Hello, Faida.
Well, I also want to thank Faida for posting the flyer to this training session. That's been a really, really great session. Thank you so much.
Okay. Thank you also, Faida, for supporting.
So thank you, Fahida. Thank you, Ridwan. Thank you, Oladimeji, for taking that bold step to join our class. Thank you so much.
Okay, so I think we're going to be drawing the curtain here today. Thank you everyone for participating, Mr. Fikat, Mr. Oladimeji. We really appreciate your presence. Thank you very much. So see you tomorrow in our next class.
All right, thank you.
Bye-bye, thanks.
Thank you.